Good day, esteemed researchers and viewers worldwide. We're thrilled to present pose priors from language models by Sanjay Subramanian, Evan Ng, Lee M. Uller, Dan Klein, Shuri Guinnessar, and Trevor Darrell. This groundbreaking research explores how computers can perceive physical contact and generate accurate 3D reconstructions of human poses, overcoming challenges faced by traditional methods. Stay tuned to discover how our novel framework, ProsePose, leverages language models to revolutionize pose estimation. Thank you. In this slide, we delve into the key motivations and problem statements of our research. Our primary motivation is to model physical contact, a significant social signal in human behavior. We aim to enable computers to accurately perceive this contact, which is a challenging task due to several reasons. One of the main challenges is the occlusion of body parts during close physical interactions. This makes it difficult for state-of-the-art pose regression models to accurately capture the pose. Additionally, 2D key points, which are often used in pose optimization methods, fail to convey contact points, adding to the complexity of the problem. Existing methods to address these issues involve resource-intensive data collection. This includes motion capture or annotated self- and cross-person contacts. However, these methods are time-consuming and expensive, making them less feasible for large-scale applications. In the next slides, we will discuss our novel approach to tackle these challenges. Stay tuned. In this slide, we'll delve into the key highlights of our work. Firstly, we leverage the semantic knowledge of poses that is implicit in large multimodal models, or LMMs. These models understand how to articulate a given pose, which is a crucial aspect of our approach. Secondly, we propose a novel zero-shot framework. This framework takes the free-form natural language responses from the LMM and converts them into tractable loss functions for pose optimization. This innovative approach allows us to refine 3D pose estimates to capture touch accurately, without the need for expensive contact annotations used in prior work. This is a significant step forward in the field of 3D pose estimation. Stay tuned as we delve deeper into these insights in the following slides. Begin Frame title key highlights, begin itemize, item key contribution, begin itemize, item we introduce ProsePose, a novel zero-shot framework that leverages the power of a pre-trained language multimodal model, or LMM, to extract a semantic understanding of human poses from written language. Item the LMM is prompted with an image and generates a formatted list of contact constraints between body parts. These constraints are then converted into a loss function, which is used to refine the initial 3D pose estimates. Item this approach eliminates the need for expensive contact annotations used in previous methods, making it a more cost-effective solution. Item our experiments show that ProsePose improves over previous zero-shot baselines in both one-person and two-person settings. Item this work suggests that LMMs are promising tools for 3D pose estimation with potential applications beyond touch. End itemize, end frame. In this slide, we're highlighting the key aspects of our method. Firstly, we refine the initial estimates of a pose regression model. This is a crucial step, as it allows us to improve the accuracy of our pose predictions. Secondly, we use a prompt that provides an intuitive way for the system designer to adapt the generated constraints to their specific setting. This flexibility is a key strength of our approach. Lastly, these constraints are not optimized in isolation. Instead, they are optimized jointly with other common losses, such as the 2D key point loss. This joint optimization further refines our pose estimates, leading to more accurate and reliable results. In essence, our method combines the strengths of language models and pose regression models to improve 3D pose estimation. Moving on to the key highlights of our work. Our experiments, conducted on 3 two-person interaction datasets and a complex yoga pose dataset, demonstrate the superior accuracy of ProsePose over previous zero-shot approaches. This is a significant leap forward in the field of 3D pose estimation. Furthermore, our results underscore the potential of language models, or LMMs, as a valuable tool for pose reconstruction. Remarkably, these LMMs don't require any additional fine-tuning to be effective. This suggests that we can leverage the inherent semantic understanding of these models to refine and optimize 3D pose estimates. In essence, ProsePose is a powerful tool that harnesses the potential of LMMs to deliver more accurate and efficient pose reconstructions. In our quest to model physical contact as a social signal, we've developed a novel approach called ProsePose. As you can see in the figure, ProsePose is a zero-shot framework that leverages the implicit semantic knowledge of poses in large multimodal models, or LMMs. Our goal is to enable computers to accurately perceive and reconstruct physical contact in 3D. This is a challenging task due to issues like occlusion of body parts and the limitations of 2D key points in conveying contact points. However, by harnessing the power of LMMs, we're able to overcome these challenges and provide a more accurate and nuanced understanding of human behavior through physical contact. Begin a frame. Frame title: A ProsePose. A novel approach. Begin a figure. Centering. Include graphics. Width equals 0.8 text width. Height equals 0.45 text height. A SRC. Task _ execution extracted _ paper _ data. 2405.03689 v1. Figures. 2405.03689 v1 figure 3:1.png. Captiona tinea. ProsePose's process of generating structured pose descriptions. End of figure. Begin itemize. Item ProsePose. A zero-shot framework. Begin itemize. Item utilizes language model multimodal LMM to generate structured pose descriptions. Item converts these descriptions into loss functions to optimize the pose. Item eliminates the need for expensive contact annotations used in prior work. Item applies to an arbitrary number of people, improving over previous zero-shot baselines. End itemize. Item LMMs. Promising tools. Begin itemize. Item show potential for 3D pose estimation. Item may have implications beyond touch, such as the back, including the waist back and shoulder back regions. End itemize. End a frame. In this slide, we introduce our proposed solution, ProsePose. This is a zero-shot framework that leverages a pre-trained large multimodal model, or LMM, to extract a semantic understanding of human poses from written language. The LMM is prompted with an image and it outputs a formatted list of contact constraints between body parts. This list is not just a simple description, but a valuable tool. We convert these constraints into a loss function that can be optimized jointly with other common losses, such as 2D key point loss. This innovative approach allows us to refine 3D pose estimates to capture touch accurately, without the need for expensive contact annotations. The image here provides an overview of the ProsePose method, illustrating how we use language to enhance pose estimation. Begin a frame. Frame title: A ProsePose in action. Begin a figure. Centering. Include graphics. Width equals 0.8 text width. Height equals 0.45 text height. A SRC. Task _ execution extracted _ paper _ data. 2405.03689 v1. Figures. 2405.03689 v1 figure 3:1.png. Captiona tinea. ProsePose's application in different scenarios. End a figure. Begin itemize. Item ProsePose's flexibility. Begin itemize. Item adapts to both one-person and two-person settings, unifying them in a single framework. Item handles variations in how body parts are referenced, ensuring accurate pose estimation. End itemize. Item ProsePose's innovation. Begin itemize. Item leverages the existing knowledge in a language model to reason about pose, eliminating the need for expensive data collection. Item improves pose estimates of state-of-the-art regressors and scenes with physical contact. End itemize. End a frame. Let's delve deeper into our method, ProsePose, as illustrated in the figure. This innovative approach refines 3D pose estimates to capture touch accurately using the implicit semantic knowledge of poses in language models. The beauty of ProsePose lies in its zero-shot framework, eliminating the need for expensive contact annotations used in previous methods. Our experiments, conducted on 3 two-person interaction datasets and a complex yoga pose dataset, have shown promising results. ProsePose has outperformed previous zero-shot approaches, producing more accurate reconstructions. This suggests that language models can be powerful tools for 3D pose estimation, with potential implications beyond touch. In the next slides, we'll explore the specifics of how ProsePose works and how we've used it to improve 3D pose estimation. Stay tuned. In our review of related works, we found that previous approaches have tackled the challenges of body part occlusion and the limitations of 2D key points in conveying contact points. These methods typically involve the creation of task-specific datasets. These datasets are curated through motion capture techniques or by annotating points of contact between body parts. While these methods have shown promise, they often require significant time and resources to implement. In our work, we aim to leverage the power of language models to address these challenges in a more efficient and scalable way. Stay tuned as we delve into our unique approach in the following slides. In this slide, we delve into the limitations of existing approaches in the field of pose estimation and optimization. Firstly, pose regression models often struggle when body parts are occluded, making it difficult to accurately predict poses in such scenarios. Secondly, methods that rely on 2D key points for pose optimization often fail to convey contact points, which are crucial for understanding interactions between individuals or between different parts of the same body. Lastly, the process of collecting training data, which often involves motion capture or annotated self- and cross-person contacts, is resource-intensive and time-consuming. These challenges highlight the need for innovative solutions in this field, which is where our work comes in. We propose a novel approach that leverages language models to overcome these limitations, as we will discuss in the upcoming slides. In our exploration of related works, we've identified some key baseline approaches. These traditional refinement methods often rely on the collection of training data, which involves motion capture or annotated self- and cross-person contacts. While these methods have their merits, they come with significant limitations. The process of gathering this data is both time-consuming and expensive, which can be a major hurdle in the advancement of this field. Our work aims to address these challenges by leveraging the existing knowledge in a large multimodal model to reason about pose, thereby bypassing the need for expensive data collection. This innovative approach sets our work apart and paves the way for more efficient and cost-effective solutions in the field of pose estimation and reconstruction. Begin a frame. Frame title our related works. Begin itemize. Item importance of related research. Begin itemize. Item our work builds on the foundation of existing research in pose regression models and pose optimization methods. Item we introduce a unique approach that addresses the limitations of these methods. We utilize a pre-trained large multimodal model, or LMM, to extract a semantic understanding of human poses from written language. Item this innovative use of language models allows us to articulate and structure pose descriptions into constraints, which are then converted into loss functions for pose optimization. Item our method, ProsePose, is a significant step forward in the field as it unifies both one-person and two-person settings in a single framework and improves pose estimates in scenes with physical contact. End itemize, end a frame, On this slide, we delve deeper into the technical aspects of our proposed research. ProsePose, as you can see in the figure, our framework is guided by large multimodal models, or LMMs, to estimate 3D body poses. ProsePose is a zero-shot framework, meaning it doesn't require any prior training. It refines 3D pose estimates to accurately capture touch, a crucial aspect often overlooked in pose estimation. The key to our approach is the use of LMMs. These models possess an implicit understanding of poses, which we leverage to generate structured pose descriptions. These descriptions are then converted into loss functions used to optimize the pose. One of the significant advantages of ProsePose is that it eliminates the need for expensive contact annotations, which were necessary in previous methods. This makes our framework more accessible and cost-effective while maintaining or even improving the accuracy of pose estimation. In the next slides, we'll discuss how we put this theory into practice. Stay tuned. Begin a frame. Frame title a proposed research and technical details. Begin a figure. Centering include graphics. Width equals 0.8 text width. Height equals 0.45 text height. A SRC task underscore execution extracted underscore paper underscore data. 2405.03689v1 figures 2405.03689v1 figure 2:1.png. Caption a tiny LMM guided pose estimation. End a figure. Begin itemize. Item the solution. ProsePose begin itemize. Item we introduce ProsePose, a zero-shot framework that refines 3D pose estimates to accurately capture touch using the implicit semantic knowledge of poses and language models. Item ProsePose generates structured pose descriptions from language models and converts them into loss functions used to optimize the pose. Item this approach eliminates the need for expensive contact annotations used in prior work, making it a cost-effective solution. Item our experiments show that ProsePose improves over previous zero-shot baselines in both one-person and two-person settings. end itemize, end of frame, backquote, backquote, backquote. In this slide, we delve deeper into our approach to the problem. We utilize a pre-trained language model, or LMM, to extract a semantic understanding of human poses from written language. This is a key component of our method. The LMM is prompted with an image, and it outputs a formatted list of contact constraints between body parts. This list is crucial as it provides us with the necessary information to understand the pose in the image. These constraints are then converted into a loss function. This loss function is not used in isolation, but rather it is optimized jointly with other common losses, such as the 2D key point loss. This combination allows us to refine the 3D pose estimates in a more accurate and nuanced manner. The figure you see here illustrates our LMM guided pose estimation process, providing a visual representation of the steps I just described. In essence, our approach leverages the power of language models to enhance the accuracy of 3D pose estimation. This is a novel and promising direction in the field. Begin a frame. Frame title at proposed research and technical details. Begin a figure. Centering. Include graphics. Width equals 0.8 text width. Height equals 0.45 text height. SRC task underscore execution extracted underscore paper underscore data 2405.036889v1 figures 2405.036889v1 figure 2:1.png captiona tinya LMM guided pose estimation end of figure. Begin itemize. Our approach, ProsePose, is a novel method for refining 3D pose estimates. It stands out from previous methods in two key ways. Begin itemize. Item first. Unlike traditional methods that rely on task-specific datasets, ProsePose leverages the existing knowledge in a language model to reason about pose. This eliminates the need for expensive data collection and annotation. Item second, we introduce the use of a language-based prior to determine which contacts are most likely in poses and interactions. This allows us to accurately capture touch in both one-person and two-person settings, improving over previous zero-shot baselines. End itemize, end of frame. In this slide, we delve deeper into the technical aspects of our research. Specifically focusing on our experiment design, we conducted experiments on 3 distinct datasets involving two-person interactions, as well as a dataset featuring complex yoga poses. The figure you see here illustrates our LMM guided pose estimation process. Our evaluation was based on the accuracy of the reconstructions generated by our model. This approach allowed us to assess the effectiveness of our model in accurately predicting and understanding complex physical interactions and poses. Stay tuned as we delve into the results of these experiments in the upcoming slides. Begin a frame. Frame title at proposed research and technical details. Begin a figure. Centering. Include graphics. Width equals 0.8 text width. Height equals 0.45 text height. SRC task underscore execution extracted underscore paper underscore data 2405.036889v1 figures 2405.036889v1 figure 2:1.png captiona tinya LMM guided pose estimation end of figure. Begin itemize. The method used. Begin itemize. We refine the initial estimates of a pose regression model. This refinement is guided by the language model, LLAVA, which generates a caption describing the pose. This caption is then converted into a table of constraints by GPT-4. The prompts used in this process are adaptable, providing an intuitive way for system designers to tailor the generated constraints to their specific setting. This adaptability is key to the versatility of our approach. End itemize, end of frame. Moving on to the technical details of our research, let's take a look at this figure which illustrates our LMM guided pose estimation process. This process is a key component of our ProsePose framework. Now, let's talk about the improvements we've made. Firstly, ProsePose has shown to produce more accurate reconstructions than previous zero-shot approaches. This is a significant step forward in the field of 3D pose estimation. Secondly, our results indicate that language models, or LMMs, without any additional fine-tuning, offer a useful prior for pose reconstruction. This finding opens up new possibilities for future research and applications in this area. In essence, our work with ProsePose and LMMs is pushing the boundaries of what's possible in 3D pose estimation. Moving on to our technical results, let's delve into the key findings of our research. our proposed zero-shot framework, ProsePose, has shown to outperform previous zero-shot approaches in reconstructing 3D poses. This was tested across 3 two-person interaction datasets and a complex yoga pose dataset, demonstrating its versatility. Now, let's look at the role of large multimodal models, or LMMs. Without any additional fine-tuning, LMMs provide a useful prior for pose reconstruction. They allow us to extract the implicit semantic knowledge of poses, which proves to be beneficial for pose estimation. Most importantly, our results suggest that ProsePose can accurately capture touch, a significant social signal in human behavior. This is a major step forward in the field of 3D pose estimation. As you can see in the figure, the LMM-guided pose estimation process is illustrated, showing how the image and bounding boxes are used to generate a list of contact constraints, which are then converted into a loss function to optimize the pose. In summary, our research not only advances the field of 3D pose estimation, but also opens up new possibilities for understanding and interpreting human behavior. Moving on to our technical results, let's take a look at this figure, which illustrates the process of LMM-guided pose estimation. Now, let's delve into the implications of our results. Firstly, our successful use of language models in pose reconstruction opens up exciting possibilities for their application in other areas of 3D pose estimation. Secondly, our results demonstrate the feasibility of a zero-shot framework in pose estimation, which eliminates the need for resource-intensive data collection methods. This is a significant step forward in the field. Furthermore, the ability of our framework, ProsePose, to accurately capture touch could have far-reaching implications for the modeling of human behavior and social interactions. Lastly, our results also highlight the potential of using written language to extract semantic priors on human poses. This opens up new avenues for research in this area. In essence, our work not only advances the field of 3D pose estimation, but also paves the way for future research in this exciting domain. Begin Frame title exploring different multimodal models. Begin Itemize. Item we evaluated ProsePose using a different large multimodal model. LLAVA. Next 34B. Item the model struggled to directly generate the table of constraints from the image, likely due to a weaker language model compared to GPT-4. Item we overcame this by generating a caption from the LMM and feeding the caption to GPT-4 to convert it into a table of constraints. Item we carefully selected prompts for both one-person and two-person experiments to ensure the best performance. End Itemize. End Frame. Begin Frame. Frame title language priors on human pose. Begin Itemize. Item there is a wealth of text to 3D human pose and motion datasets, enabling work on generating 3D motion sequences of a single person or two people conditioned on text. Item previous methods like PoseScript, PoseFix, and PoseGPT have made significant strides in this area. Item however, our work differs in several ways. We leverage existing knowledge in an LMM to reason about pose, we unify both one-person and two-person settings in a single framework, and we improve pose estimates in scenes with physical contact. End Itemize. End Frame. Begin Frame. Frame title exploring further possibilities. Begin Itemize. Item future directions. Begin Itemize. Item we have seen that ProsePose can be applied to an arbitrary number of people, opening up a wide range of possibilities for future research. Item the framework's ability to handle variations in how the LMM references body parts, such as left and right limbs, shows its adaptability and potential for further refinement. Item the use of different LMMs, such as LLAVA, Next 34B, demonstrates the versatility of ProsePose and its potential for integration with other models. Item the exploration of guiding pose optimization with an LMM, as illustrated in Figure 2, hints at the potential of LMMs in other applications beyond pose estimation. End Itemize. End Itemize. End Frame.